Hey there, everyone. In today's video, I want to talk about causal artificial intelligence, and we're going to be using Python, Jupyter Notebooks as usual. I use these for all of my demos and training exercises and teaching lessons. So what is causal AI? It helps us determine how changes in one variable, this is the cause variable, leads to changes in another variable, this is the effect variable, right? So we're going to look at cause and effect. This is crucial for making informed decisions, understanding mechanisms, how different features are related to each other, and predicting effects of interventions. Okay, so what is the difference between causal relationships and correlations? A correlation measures the strength or direction of a linear relationship between two variables. It doesn't have to be linear, but most correlation analyses are linear. There's some that handle nonlinear types of relationships. I have another video that gets into that. But for all intents and purposes, most are linear. Causation is a little bit different. It indicates that there's a change in one variable that directly causes a change in another variable. That's what we're going to look at today, okay? And ultimately, causal AI is about understanding and or quantifying cause and effects and relationships of data. So this data set is coming from right here. I believe this comes from the World Bank. I referenced the data source at the end of my video. Let me see if I can scroll down at the bottom of this notebook and check that out real quick. So if we scroll down, I think it's World Bank. I looked at a couple different data sources. Yeah, World Bank right there. So I'm giving it to you right at the end of the video. Okay, so you'll have that, and I'm going to download all the source code in this file and share it with everybody so you have that. Okay, I don't expect you to understand all the details of the data and what we're doing here today, but just understand the concept. You can download this code, you're going to have the data you can download and play around with it and interact with it and learn, hopefully, a ton about this topic. And then, sorry, I have a cold. Persisting for several days. It just won't go away. But hopefully you can learn this concept and understand it and apply it to your own situation and apply and solve your own specific scenarios. That's my ultimate intent here. And with all my videos, I try to make the examples very relevant, very useful, but also generic. So if it's very, very customized, you might not be able to pick it up and apply it to your specific use cases. If it's more generic, you should be able to say, yes, I understand this concept and I have data that is similar, slightly different, but somewhat similar to yours. I can take it, do a quick lift and shift, and then solve my own specific problem. So I try to make all my videos relevant to the task at hand, but generic enough so anybody can take this concept and apply it to their own specific use case. So one thing I'll mention is I have 3 models here. I'm not going to run these because it takes quite a bit of time to run, at least 20 to 25 minutes, and I do not want this video to drag on and on and on. That's not my intent here, so I'm going to run through pretty quick. I'm not going to refresh the data, but once you download the source code and run it on your own Jupyter Notebook, you're going to see exactly what I see, and you'll see how all these things fit together and how everything interacts, right? So we have the data frame. That's the data source. It's abbreviated DF. Treatment, outcome, and common cause. These are the variables that come from this data set. If I go up just a little bit, interest rate, original principal amount. Oh, I'm looking at the far right. Most of these come from the left. Let's move over. Interest rate, original principal amount. Okay, country economy, interest rate. Okay, so you can see the variables right there. So that's what we're using in this model. We have a causal model, and I go ahead and run it and get the outcome. And after about 25 minutes of running, it says negative 3601144. So what is that? Okay, we're basically saying the interest rate is the treatment variable, the outcome variable is the original principal amount. So the interest rate is the independent variable. You don't control the interest rate, that's independent. But what is dependent on the interest rate is the principal amount of the loan, right? So if you have looked at some of my other videos, I talk a lot about machine learning, and you'll see a lot of independent variables being fed into the X variable, and the dependent is the Y variable, both for regression and for classification models. I've got a whole bunch of videos posted on YouTube about that. You can go check those out. So the concept is similar here, but slightly different. You're also dealing with independent and dependent variables. but we also have a common cause. We're using these canceled amounts, loans held, region, country, economy, and project name. This is really called a co-founder, and this is showing us which portion of the original principal may be canceled and which can affect the amount dispersed, right? So whatever lending institution that we're going to get the money from, hopefully, is going to disperse a certain amount based primarily on the local interest rates, right? And as the interest rate increases, the amount of the loan will decrease, right? An increase of 1% results in a decrease of 3.6 million, right? So let's go down here just a little bit. I have more information in my notes. This is all very useful, very interesting. If the higher canceled amount was not accounted for, it could be falsely inflating or deflating the effect of the interest rate. So that's why you're using this as a common clause, right? We're also controlling and accounting for the loans held. This can affect smaller loans, and this could skew the effects on the interest rate or the loan amount, right? We don't want to have influences or biases on this, so we're going to control that. Controlling for the region, we can ensure that the interest rates are isolated from geographic influences, right? There could be political unrest or geographical regions at war. We don't want that to have an impact on the interest rate or the amount borrowed from a bank. Furthermore, controlling for country or local economy ensures that the cause and effect of the interest rate on the loan size is consistent across all countries, right? So this is very different from machine learning. Rather than trying to predict a certain outcome or classify a certain feature, we're now using independent and dependent variables, adding and controlling factors called common clauses. And once we can control for that, we can add more stability, have more confidence in the model that it's doing what it's supposed to do, right? And not introduce these biases or these weird confounding outcomes, right? We can have a pure cause and effect. That's what we want to know. We don't care about training the model. We don't care about correlations. We want to know what causes a certain thing to happen, right? So we have the cause, we have the effect, and this is handled very elegantly in this type of model. So let's go down a little bit more. I'm pretty happy with the way that turned out. I think it's doing exactly what it's supposed to do. Again, we have the interest rate and the canceled amount. Now, it's not the amount issued, but the amount that's canceled by the lending institution. And then again, for common clauses, we have loans held, region, country, economy, and project name. This is what we're trying to account for or trying to control for. So similar to before, we say 1% in interest rate increases. Again, interest rate is the independent variable. The number of loans held decreases by 250K, okay? So 250,000 decrease for an increase in interest rate, and we're holding those other variables constant, right? Or accounting for those other variables with just slight minor changes. And again, these common causes are canceled amount, region, country, economy, and project name, okay? So let's look at one more example. Again, this is going to be interest rate as the independent variable. I'm sorry. Let me take one step back. I think I went too fast and skipped it. I think I went to the third model, not the second one. Okay. So we saw the 250K decrease of loans held when interest rates increase 1%. I jumped the model 3. I should have gone 1, 2, 3. I went 1, 3. I'm going to hit 2. So just to explain that, we have a similar scenario, just changing some of the inputs slightly. So again, we have the interest rate as the independent variable, the canceled amount as the dependent, and then the common clauses is what we're controlling for. This is loans held, region, country, economy, and project name. We run the model, we get negative 1.3 million. Okay, and that is going to jive with what we saw before. Every increase in an interest rate of 1% causes the canceled amount to decrease by about 1.33 million, okay? So this basically shows us that the canceled amount is equivalent to the interest rate plus the loans held plus the project name plus the region plus the country and all those variables divided by the economy, okay? So this regression equation uses a cause and effect. The dependent variable is the canceled amount. This is the outcome, and the interest rate is the treatment. This is the independent independent variable, right? So pretty nice. We have some pretty easy and straightforward inputs and easy to understand outputs that go nicely together. So in this cell, I am cleaning up the computer gets very jumpy here when I turn on the recorder, which is unfortunate. I don't record too many videos, just 1 or 2 per day. But whenever I record video, it gets jumpy, and without the recorder on, I can't record the video. So it's like between a rock and a hard place here. I can't record the video without jumping, and if I turn off the recorder, there's no jumping, but then there's no output, right? So I don't know what to do here. Maybe find a new video service. But anyways, I'm trying to clean up the data in the data frame and just make everything consistent. So I have data frame and then the values or the features in the data frame, the column names, interest rate, principal amount, cancel amount, and loans held. These are all numeric, so I want to convert that to numeric. I want to make sure that the repayment date, first and last repayment date, are actual dates and not something else. Sometimes they come in as strings or objects or who knows what. The data isn't always clean and as straightforward as you would think. That would be nice, but in the real world, it just doesn't always work like that. And we're converting region, economy, and country, economy, and project name and a category, so the computer can easily understand what these are. So the computer doesn't know what United States, Canada, Spain, France, and Italy is. It has no idea what those things are, right? But if you take those countries and convert those into categorical codes, 1, 2, 3, 4, 5, it can start to understand what those things are. So we convert everything into numerics whenever we're doing with some type of modeling or machine learning or data science type of experiment. Everything has to be numeric or one-hot encoded or categorical encoded or label encoded. But you can't just feed in strings as inputs because the model is going to crash. It's just going to basically say, I have no idea what this is, and we can't proceed. So we're going to clean that up and then move on with basically with some graph analysis. So this is pretty cool because we can start to understand, based on the causal model, the edge weights, and then visually plot this and render this in a chart to show us the weights and the importances between all the nodes, and the weight will show us the significance or the meaningfulness between the different nodes. So we don't have to get into all the details of the code here. It's kind of straightforward. If you go to the graph analysis documentation, you can Google that and find that online. It took me a little while to figure out how this works, but it's not insurmountable by any means. It does take a little time, but whatever time you invest in it, you absolutely get out of it, and you can draw some very visually appealing, very profound types of network graphs when you understand the concept. So I'd encourage you to check out that documentation. I'm going to share this code with you, so you have this code, you'll have that code. I think you can piece it together and figure out how it works. So when I run this, I get this output out down here with all of the nodes and then all of the weights between all the nodes. So I have interest rate, original principal amount, interest rate, canceled amount, loans held, region, country, project name, so on and so forth. And then the next relationships, original principal amount and interest rate, canceled amount, loans held, region, country, project name. So we have every possible combination of all of these features that's in our data frame, right? So we see here the plot and the relationships and the strength of the relationships between us. So we have interest rate, loans held, principal, region, project name, country, economy, canceled amount. So pretty cool stuff. We have everything that we need to start to understand the analysis. And if we go up here, I see negative 8.3 for the first weight between the features. So very low weight, because this is exponent to the negative 9, right? So you have 1 with 9 zeros after it and divide that by 8.3 to get this. So almost no relationship between loan held and interest rate. And if we go ahead and move up a little bit, we should look for loans held and interest rate first. And where is it? Loans held and interest rate. Okay, I see it. Loans held interest rate. Okay, we see 0 because we're only going up to 4 decimals. It was negative 9 decimals or negative 8, I think, and then we start to get a decimal. So we really see a 0 there. That was the first weight that we saw between the first two nodes. Let me scroll down a little bit. So 8.3 negative e to the negative 0.9. So pretty pretty trivial weight there, but let's find one that's a little bit more significant. Maybe loans held to project name. I see 1940 loans held to project name with a weight of 1940, so that is pretty significant. Loans held to project name. Let's go up a bit. Loans held to project name. And I see 1940. Let me search for it. 1940. Oh, project name to loans held. Okay, so now we're going the reverse way. Project name to loans held. The causal effect is 1940. So that's a pretty strong effect between the project name and the loans held rate. 1940, you can see that kind of in the middle there. So that's pretty useful, although this version of the graph is not interactive, and it's a little bit busy. There's a lot going on there. So is this ideal for handing off to a client or handing off to a key stakeholder that we're working with? They might not understand this, and it's going to take a little bit of work to really explain this. So I would probably recommend a slightly easier graph to work with, and really leverage the power of PyViz. PyViz is a pretty cool library that I found fairly recently, not too long ago, and it creates similar charts to what we saw above, but it's all interactive. So the weights, again, show the meaning or the impact magnitude between the nodes. The effect or the size of the coefficients is relative to the weights rate, the strength, and the causal relationships is displayed there. And again, intuitively, this should show you the importance or the influence between the nodes, right? The bigger the number, the more important. The smaller the number, the less important. That's all that is, right? And any kind of weight that's close to 1 means that has a very strong relationship between the nodes. The height weight closer to 1 shows a strong relationship that's very important. A low node weight shows close to 0, means that the edge has a weaker effect and is a lower importance, right? But the weights can also indicate relationships that are relative to the influence of different factors, with higher weights suggesting greater importance or influence and lower weights showing less influence, right? And that's what we would expect. So let's go down here to see a visual rendering of a PyViz graph analysis. So this is similar to what we saw above with the edge weights and all the nodes, right? And we'll see the relationships between those, and larger, bolder numbers indicate stronger relationships, just like we saw above. So I'm going to do the same thing. I'm going to print it. I'm going to print all the outputs, and then I'm going to show you the visual rendering of the image. I always say a picture's worth 1,000 words, and it really is, right? If I took all of this detail right here, where's my mouse? If I took all this detail and I had to break that down for a client, explain that would be convoluted, it would be cumbersome, it would be a little bit confusing, and I don't know if anybody would benefit from all this. This is just showing us below what actually the numbers are. We're printing out everything, so it's a little bit easier to interpret this. But really, I think this picture is much more important, right? A picture is worth 1,000 words. Rather than spending 1,000 words to try to explain what's going on, we have this visual rendering, which is actually animated. When you pull on one side, all the other pieces of the node follow you around. Okay, because everything is related to everything else, right? And as you move it around, it's going to follow the mouse, right? And again, the weights show the importance between all of these nodes, right? With the darker numbers being more important and being larger, and smaller numbers being less important and having less weight, so less significance and less influence, right? Let's try to match up one or two of these. If I go over here, I see a 10 point, or I see a 0.57. If I go up a little bit, it's 0.57. Control F, 0.57. I see it, yeah, right there. So original principal amount to loans held, and the weight between these two is 0.57. So in this case, closer to 1 is stronger, 0 is less, right? We're looking at original principal amount to loans held. So it's not huge influence between these. but it is about 1/2. So we're halfway up to 1, 1 being the strongest, 0 being the weakest. And if I pick up this part of the node, we should have original principal amount to loans held. And it's the original principal amount right there. Can we get the loans held? Oh, I see it. Yeah, it's just pulling out. It's just pulling away from the others right there. So you can see the relationship here. There's a slight lag because my computer runs so slow. I have no idea why. It's only when the recorder's on. I have to look out for a new recorder. But once you create the graph analysis diagram here and plot it and see all the relationships, you can see which have stronger relationships and which have less relationships. And we already know from the examples above the cause and effect on all of these relationships, right? So overall, I think that's pretty interesting analysis. And there's so many different applications, right? If one thing happens, what caused that thing to happen? If one thing didn't happen, what caused that not to happen, right? So there's a cause and effect for so many variables in the natural world, in the business world, and in the academic world, of so many different things, right? And if you have a good data set here, I picked one from the World Bank, you can do all kinds of analysis and understand all kinds of insights into cause and effect that you would never get from traditional data science or machine learning types of models. So I think that's it. The data source is listed here. I'm going to download this source code and share it with everybody. I learned a couple new tricks putting all this together today. I hope other people learn something too. I try to learn something every day. If I learn 2 things in one day, that's just a bonus. I try to learn at least one new thing every single day. I try to not make it through the day without learning one thing. So hopefully you learned something today as well. Thank you for the time that you've dedicated to watching this video. And as always, enjoy the rest of your day. Thank you. Goodbye.